Okay, in example 4, we're going to learn a shortcut for polynomials to recognize whether your polynomial is an even, odd, or neither function. Now, this shortcut only works for polynomials. It won't work for absolute values, it won't work for square roots, it won't work for rational functions, just polynomials. So, in a polynomial, if it's even, all of the exponents in the variables are going to be even exponents. If it's an odd polynomial, all of the exponents in the whole polynomial, all those variables, are going to be odd exponents. So, for example, when we look at c of x equals x to the 6th, right, 6 is an even exponent on a variable. Then that's minus 2x squared. The 2, that square, is an even exponent on the variable. Okay, at the end we have a constant, and if you remember from earlier lessons, constant is an x to the 0 power, right? Because anything to the 0 power is 1, 1 times 3 is 3. So a constant function is not linear, it's a polynomial of degree 0. So this is a degree 0 term, and 0 is an even number, so that has an even exponent as well. And even, all of these exponents are even. That makes this an even function. Okay, if we were to look at the graph of that function, so if we bring up the calculator, we'll go ahead and clear these out from before, and we'll type in x to the 6th minus 2x to the 2nd power, and then plus that constant 3, and zoom 6, and then we'll let the graph come up. So if we look at the shape of that W graph, right, you can see that y-axis symmetry that tells us that that is an even function. So this x to the 6th, the 6 is an even exponent. Then on our constant term, negative 3x to the 0 there on the x, that's an even exponent. And that makes this function, f of x, an even function as well. Okay, in d of x, we have x to the 3rd power minus 3. Now the exponent of 3, that's an odd exponent. The constant, though, is, remember, x to the 0 power, and 0 is an even exponent. If you have a mixture of even and odd exponents in your polynomial, that's neither even nor odd, because it can't be both. So this one we would classify as neither. Okay, and then when we look at this last example, e of x, we have 4x to the 5th. 5 is an odd exponent. That's minus 2x to the 3rd. 3 is an odd exponent. And then plus 3x, this is our linear term, so x is to the 1st power, and 1 is an odd exponent. So odd, odd, and odd, that makes e of x an odd function. And we can verify that in the calculator by graphing and looking for rotational symmetry about the origin. So 4x to the 5th power minus 2x to the 3rd power, and then plus our linear term 3x, and we'll look at that graph. And we can see that origin symmetry, right, as the graph comes through 0, 0, and if we were to reflect in the x-axis and then the y-axis, we would see the symmetry. If we hit trace and type in a value for x, like 1, right, we get back 5 for y. If we type in negative 1, we should get back negative 5, right? That would verify that this was an odd function, and it does.